Hello guys. Today is the continuation of the fifth lecture of chemical kinetics. So first we see what we have studied in the previous lecture. So in the previous lecture we have studied about the zero order kinetics. So for zero order kinetics, reaction should be you have in any textbook you have seen that there is one type of reaction, that is A goes to product. 99% in cases you will see reaction A gives product. In 1% cases there shall be some different type of reaction for zero order kinetics, but that is not in the course of the 12th standard. That is will be included for the competitive exam. For A gives product, and for zero order reaction, rate should be written like K e to the power 0, where rate of reaction or rate is not dependent on the concentration of reactant. So rate is just equal to the rate constant, which is a constant value. So if we make a graph of rate and concentration of A, since rate does not depend on the concentration of A, and it is equal to the rate constant, which is a constant value, and it depends only the temperature of the reaction. So we are not talking about temperature here. So K is constant here, and since K is constant, so rate should be constant with respect to the concentration of A. Same rate is constant with time also, because there is no time term in the rate expression. So for zero order reaction, we have seen that rate is constant with respect to T and with respect to the concentration of reactant. Okay. But if we talk about the reaction, since A gives product, A will consume and gives product P or any product. So over a time period of the reaction, A will decrease and A will decrease and product will increase. So reactant, and this is product. A will decrease and product will increase. So you can see that if reaction is in the forward direction of time, you can see that reactant will consume and product will form. So reactant will decrease. But if we talk about the rate is constant. At each time, A is consumed with same rate and product is formed with same rate. So it is very important that rate should be a constant, but your reactant should not constant. Reactant will decrease over time period and product will increase over time period. So this is very important. So please consider it very important. So now we we have solved the integrated rate law for zero order reaction, and then we have find that how concentration of A depend on the time. So for reaction A gives product, we have get the expression that A is equal to A naught minus KT, where A naught is your initial concentration, A is your final concentration at time T, and K is your rate constant. Okay. And then we have solved, and then we have make a graph for concentration, how concentration of A decreases with respect to time. So this is the graph that as time increases, concentration of A decreases. It should be decreased because it is a reactant, and the slope of this line will give you the rate constant. So if you have only this type of graph, so and you have asked that what is the order of the reaction, so you have to write just zero order reaction, and if they ask for the rate constant, just find the slope of the line to get the rate constant from the graph. Okay. Then we have talked about the half-life of reaction. Half-life is represented by T half. So what does half-life represent? Half-life means 50% of the reactant is consumed. So at what time 50% of the reactant is consumed, we have to find the T half. So at name suggest, uh, at time T half, we have left only A naught by, if initial concentration is A naught, so we have left at T half A naught by 2. So use the equation of A is equal to A naught minus KT for zero order reaction. For the reaction A gives product, and then for that type of reaction, we get TF is equal to A naught by 2K, where A naught is initial concentration, K is rate constant. So T half for zero order reaction is a constant value, which will depend upon the initial concentration of the reactant and rate constant. Okay, then we have talked about the lifetime of reaction. Lifetime of reaction is represented by TLF, and lifetime of reaction defined as a when your reaction is 100% complete. For as name suggests, 100% complete, since so we know at T is equal to TLF, the concentration of reactant will be 0. So put in the equation of A is equal to A naught minus KT, that for the reaction type of A gives product, and we get TLF is equal to A naught by K, and T half we get A naught by 2K, and TLF we get A naught by K. So TLF is 2 times of T half. So we can say that for zero order reaction, we can use the unitary method. If we know 100 to 50, we get 10 minutes of time. So 50 to 0, we get 10 minutes of more time. So from 100 to 0 for 100% completion for that type of reaction, we get 20 minutes of completion. So we can use a unitary method in zero order reaction, and this is the example for that. If we know 100 to 90, we get a time T. So for 80% completion, we get 80 times. It's just a unitary method. And for 60% completion, we will get a 60 times. So uh, so this is the shortcut method we can use to save time for a competitive exam, but for the board exam, we have to use the whole step to get the final result. Then we have solved some numericals, and in that numerical, we have talked about how to solve step by step and how to solve a shortcut method, that is unitary methods. Okay, so in today's lecture, that is lecture 5 B part, continuation है, continued or not be, if we write lecture 5 continued. So in today's lecture we will talk about some other type of examples, and then what is the graph of the zero order reaction, then some examples, and then special cases where your A to this product reaction is not followed. So question number 1 is, for a reaction the time required for 20% completion is 40 minutes, and for 40% completion is 80 minutes. Find the order variation and rate constant. Find the order of reaction and rate constant. Now solution. The question is, for a reaction, the time required for 20% completion is 40 minutes and for 40% completion is 80 minutes. So for that type of reaction, we have to use the hidden trial method. So the algo for this type of reaction is that first we use generally the important order is first order reaction. The most probably the questions come from the first order reaction. So first we start from guess the first order reaction. Guess the order of reaction. So first we start from the guess order of reaction. Order of reaction. So then we use the rate law of that order of reaction. Rate law of that order of reaction. Order of reaction. Then from that rate law we find the rate constant from two data, from different data. Rate constant from different data. So find rate constant from different data. Then we just check. Then we just check K1. Let's both data are K1 and K2. Then we check K1 is equal to K2 or not. If it is yes, then we have result. Then we stop and print the result. If it is not true, then we go to first step, that is order of reaction. So this is the algorithm for this type of reaction, that first we have to guess the order of reaction, then the rate, then indicated rate law expression for that order of reaction, use the indicated rate law. Then from that rate law and the given question, we find the rate constant. And if both the rate constant from both the datas, if the rate constant is similar, then we have the order of reaction. And if it is not similar, then we have to guess it again. So for this question, it is, we can see from the question also, for 20% completion is 40 minute and 40% completion is 80 minute. It is from unitary method, we know that it is a zero order reaction, but for board exam, for board people, I will do how to solve it. So for reaction of type A gives product, which is which is in this case. So for A gives product, equation of zero order reaction is A is equal to A naught minus KT. And we know and the question is given is 20% completion, that is we have 0.8 A naught is equal to A naught minus K into 40 minutes. And it comes out to be 0.2 A naught by 40 is equal to K from first equation, or we can say that K1. And second data is 40% completion, that is we at final we have 0.6 A naught minus K into 80. So we get 0.4 A naught, it should be K2, divided by 82 is equal to K2. Now we get from first and second, 0.2 A naught by 40 is equal to 0.4 A naught by 80. A naught 0.2, 2 by 40 is equal to 4 by 80. It is 1 by 20 is equal to 1 by 20. So we can say LHS is equal to RHS. Hence zero order reaction. And for rate constant, K is equal to 0.2 A naught by 40. 0.2 A naught by 40. And we have 0.2 by 4, 1 by 200, 1 by 200, 1 by 200, 0.005. 5 by 1000 now. 1 by 200.005 A naught. This is your rate constant. So rate constant K is equal to 0.005 A naught. And zero order reaction. Okay, this is how solve this type of reaction. Now we talk about some graphical representation of zero order reaction or some graph of zero order reaction. We have already talked about the rate and concentration graph, but let's we talk about once more. Graph for zero order kinetics. Kinetic. So we know that rate with respect to concentration of reactant and reaction is type of A to P. A gives product, or we can directly write concentration of A, or we can say concentration of reactant. So this should be a constant value because for zero order reaction, it is not dependent on the concentration of A. And another graph should be rate with respect to time. It should also a constant value because rate is not a function of time. And then we have concentration of reactant with respect to time. This is time. This is concentration of reactant. It should decrease, and the intercept should be A naught. Here 0, and this angle or this angle and 10 pi minus theta should be minus k or k. Sorry, k minus k, because formula is your A is equal to minus kt plus A naught. ठीक है, minus k. This should decrease. It is come from this equation. You can see directly that concentration of A should decrease over the time period. Then we have a graph of half-life, T half, with respect to initial concentration. So as initial concentration increases, T half increases, and this angle, if this angle is phi, then 10 phi is equal to 1 by 2k. Okay, so slope of this line will be 1 by 2k. If we know the graph of T half versus concentration of initial concentration of reactant, if we know this type of graph, then from that graph we can find the rate constant, because the slope of that graph will give you 1 by 2k. Okay, then we have one more graph, and that graph should be concentration of product, concentration of product with respect to time. So it should also increase. So the reason is simple. If A decreases, P increases. Since A decreases linearly, so P increases linearly. This we can say from the logic also, and from math I will prove it from the math also. If A gives P and at t is equal to 0, A is A naught and P is 0. At t is equal to t, A naught minus x is consumed. So this is x, and it is A naught plus x. So from equation, A is equal to A naught minus kt for zero order equation. And here at time t, we have A naught minus x. So A is A naught minus x. And here this is A naught minus kt. A naught cancel out, minus x equal to kt. It is kt. So x is equal to kt. So x is equal to kt. Similarly, y is equal to mx. So it should increase, and the slope, that is, I think, psi, the 10 psi is equal to. So we have total of 5 graphs. For zero order reaction, rate is always a constant value until unless temperature is constant. So which is equal to the rate constant. So we can say it is equal to k. And rate with respect to time is also constant because rate is not changed with respect to time. And concentration of A will decrease as time increases because reactant consume and product form. Since A is consumed, so A should decrease, and since A A decrease with a constant rate, that's why we have a straight line with a negative slope. Otherwise, we may have something curve like, if rate is not constant. If rate is decreases or rate is increases, we may have different type of curve. But here rate is constant with respect to the concentration of A. That's why we have a straight line with negative slope. Then we talk about the half life of the reaction. So for zero order reaction, half life is equal to A naught by 2k. So with respect to A naught, it is a constant line with a slope of 1 by 2k. And for concentration of product, it is a constant line with a slope of k. So we have three type of graph, that is concentration of A, that is concentration of reactant, concentration of product, and TF. If any one of these graph is given and the slope of that line is given, we can easily find the your rate constant and order of the reaction. Since TF is increases with initial concentration, it means it is a zero order reaction, and the slope of that line will be a 1 by 2k. If concentration of product increases linearly, it means we have a zero order reaction, and the slope of that line will give you a rate constant. Okay, so this type of graph uh, is important for zero order reaction. So next we will do the examples. What are the real life example that follow a zero order reaction in which your rate is constant but your uh, concentration of reactant is decreases? So Examples of zero order kinetic example of zero order kinetic. Example is like photochemical reaction. So photochemical reactions. Reactions. Photochemical reactions. So all the photochemical reactions you have seen, it follows the radical graph reaction type. Means we give intensity of light, that is h mu, that is photons. We give photons, and from that photons, what happened? Your hydrogen molecule will convert into the hydrogen free radical, and chlorine molecule will convert into your chlorine free radical, and that free radical will bombarded each other and form a HCl molecule. Experimentally, for only this reaction, not this type of reaction, only this reaction, that is H2 plus Cl2 in presence of light gives to HCl, the rate is found to be rate is equal to K H2 to the power 0 and Cl2 to the power 0. It means rate is equal to K, which is a zero order reaction. Which is a zero order reaction, and also rate is directly proportional to intensity of light. If the number of photons are more, then rate is fast, and number of photons is less, then rate is slow. It means your free radical H2 and H free radical and Cl free radical will form fast if photons more, intensity of light more, and intensity of light less, then your H and Cl free radical will less. Second type of reaction is your enzyme catalysis reaction. Enzyme catalysis reaction. For this type of reaction, see example from book, any book. And third type of your reaction is dissociation. Dissociation of gases on solid surface at high pressure. At high pressure. Dissociation of gases at high pressure. So for this type of reaction is ammonia molecule at high pressure dissociate into N2 and H2. So this type of reaction rate is found to be K NH3 to the power 0. It means rate is equal to K, which is constant, which is zero order reaction. Yeah. So these are some example to for a zero order reaction. Now I will talk about the special case of zero order reaction where A gives product type reaction, where reaction is different than A gives product. So is spatial zero order kinetics. Zero order kinetic. So what is the spatial? So we will talk about in terms of question. Question number one. Spatial thing is that we have 3A gives product, not A gives product. We have some stoichiometric coefficient with A. Then what happened? And this type of relation rate is given. In question, we have given rate is equal to K, A the power 0, and initial concentration of A is initial concentration of A is equal to A naught. Find आपको करना है find first concentration of A after time t. एक्सप्रेशन निकालना है आपको concentration of A after time t, and second half life of A, half life of A of reaction of A निकाल दो, रिएक्शन निकाल दो, बात एक ही है. सो सॉल्यूशन कैसे होगा? हमें रेट गिवन है, तो रेट हमारा गिवन है R इज इक्वल टू K, एंड फ्रॉम द फर्स्ट लेक्चर वी कैन राइट आल्सो rate is equal to R is equal to minus 1 by 3 dA by dt. We can write this. So just this rate is equal to this rate. So minus 1 by 3 dA by dt is equal to K. So dA by dt is equal to minus 3K. dA is equal to minus 3K dt. Sorry, 3K dt. So integrate dA, and 3K is your constant. Integrate dt. At t is equal to 0, it is given initial concentration is A naught, and at t is equal to t, concentration of A is A. So A naught minus A minus A naught is equal to minus 3K t minus 0. It gives A is equal to A naught minus 3KT. A is equal to A naught minus 3KT. Now for this is your first part. Now for the half-life, since if reaction is 3A2 product, so at t is equal to 0, it is A naught, and t is equal to t half, it should be A naught by 2. And we have equation is A is equal to A naught minus 3KT. So A naught by 2 is equal to A naught minus 3KT. So A naught by 2 minus A naught is equal to minus 3KT. So minus A naught by 2 is equal to minus 3KT. Minus cut किया. So on this T is your, this T is T, this T is your T half. So T half is equal to A naught by 6K. Yes. No. Now, what we can do, we can do, we can derive a general expression for that also. So we have, if here anything, we can write it directly. We don't have to always derive it. So general case, general case, that is the stoichiometric coefficient of A is n, Na gives product, rate is given as k because for zero order reaction, and from the first lecture we can write rate is 1 by n d a by dt, and so compare both. So 1 by n dA by dt is equal to k. So dA is equal to minus nk dt. Here n is your constant because it is a stoichiometric coefficient. So integrate it. Integrate from t is equal to 0, where A is your initial concentration, t is equal to t, A is A, which is final concentration. So A minus A naught is equal to minus nkt. So A is equal to A naught minus nkt. Okay. And for T half, so I will do it here. If Na gives product, so T is equal to 0, A is A naught, and T is equal to T half A naught by 2. So we use this equation. A naught by 2 is equal to A naught minus nkt half. So A naught by 2 is equal to nkt half. So T half is equal to A naught by 2 nk. So we can say here A is concentration of reactant A at time t. A naught concentration of reactant A at time t is equal to 0, or initial concentration. K is rate constant of reaction. N is stoichiometry coefficient. Stoichiometry coefficient of reactant A, and T. T is your time of reaction. Similarly, here T half is directly proportional to concentration of initial concentration, and inversely proportional to your stoichiometry, and inversely proportional to your rate constant. So if we make a graph of T half versus initial concentration for this type of reaction, we get T half with initial concentration. So we get this graph. Okay. And the slope, which is theta, tan theta will be 1 upon 2 nk, where for A to product it is 1 by 2k. Here we get 1 by 2 nk. Okay. If we make graph of concentration with respect to time, A naught with respect to t, so it will start from here and here. Here it is A naught, and the angle, if this angle is theta, so tan pi minus theta is equal to minus nk. So the slope will be minus nk, not k. Here we have the stoichiometric coefficient. So for special case of type, if there is stoichiometric coefficient attached with the reactant, so we have everything is same except we have there is a multiplication of stoichiometry in everything in the slope. So for t half, we have 1 by 2 nk slope instead of 1 by 2k. And for concentration to time graph, we have minus nk slope instead of minus k. And for product graph, if we make a product graph for product के लिए तो दूसरा पे लेना ही पड़ेगा. Okay, control M. Okay, whatever. So where we have here, we use control. Yeah. Okay, so for product, for product, uh, right direction 3a to p at t is equal to 0. It is a naught and this is 0. At t is equal to t, it is a naught minus x and this is x. And for this type of reaction is not 3, we use n. A naught minus nkt, and a is your a naught minus x, and this is a naught minus nkt, a naught minus, so minus x is equal to minus nkt. Here x is equal to nkt. So if we make a graph for product p versus time, we will get a straight line with a slope of nk. So where for a to product we get slope of k, for na to product we get nk. So just multiply the stoichiometric coefficient. Now question number 2. Question 2. Let us consider if we have question 5 by 2a gives product and date is given is k. Initial concentration of A is A naught. Initial concentration of A is equal to A naught. And we have to find first concentration of A at time t, and second half-life of reaction. Half-life of reaction. Okay, so I will solve here. Solution. So फ्रॉम जनरल इक्वेशन क्या थी? जनरल इक्वेशन है ए इज इक्वल टू ए नॉट माइनस एन के टी, and here n is equal to 5 by 2, then use 5 by 2, so a is equal to a naught minus 5 by 2 kt, which this is your final expression for a. First question complete. And t half, what is the general equation for t half? A naught by 2 and k, n is 5 by 2, so a naught by 2 into 5 by 2k, so a naught by 5k. So t half is equal to a naught by 5k. How simple it is. Now there is one more variation of for zero order reaction, and this is last variation. Question 3. And variation is like a plus 2b gives product. Instead of only one reactor, we have two reactants. Then what happened? Then how to solve? So rate is simple. Rate is k, a to the power 0, b to the power 0, because we use zero order reaction. And initial concentration of of A is A naught and B is B naught. Find, आपको वही करना है. Find concentration first. Concentration of A and B at time t. Second, half-life of A and B. Half-life of A and B. ये निकालना है आपको. इसका आप एग्जाम्पल भी दे सकते हैं. मैंने एग्जाम्पल कराया था जो फोटोकेमिकल रिएक्शन थी. सो फोटोकेमिकल रिएक्शन में अगर आप देखें, हियर वी हैव H2 and Cl2, टू रिएक्टेंट, बट ऑर्डर इज 0. सो इसके लिए कैसे निकालेंगे? सिंपल है. हम इसके लिए क्या कर सकते हैं? इसके लिए आप दो बना लीजिए भाई. एक ए के लिए बना लेते हैं और एक बी के लिए बना लेते हैं. और सिंपल सिंपल है. हमने मान लिया ए के लिए रिएक्शन चल रही है 1 गिव्स प्रोडक्ट, बी के लिए चल रही है 2 बी गिव्स प्रोडक्ट. या हाफ प्रोडक्ट कर लीजिए इसको. हाफ प्रोडक्ट तो दोनों मिला के दो प्रोडक्ट हो जाएंगे, दोनों को जोड़ेंगे. ठीक है, p/2 वो मतलब नहीं है. ठीक है. देन व्हाट हैपन कि ए सी प्रोडक्ट के लिए तो हमें पता है था ना इक्वेशन, ए इज इक्वल टू ए नॉट माइनस के टी. बस यूज कर लीजिए इज इक्वल टू ए नॉट माइनस के टी. तो ये आपका हो गया, ये आपका हो गया ए नॉट के लिए कंसंट्रेशन का कैसे कंसंट्रेशन ये चेंज हो रही टाइम के हिसाब से. और टी हाफ आपका हो गया सिंपली ए नॉट बाई 2k. और 2b2 प्रोडक्ट है तो इसके लिए आपका लग जाएगा b इज इक्वल टू बी नॉट माइनस एन के टी. और n के लिए यहाँ पर 2 रख दीजिए, तो b इज इक्वल टू बी नॉट माइनस 2k t. और ये हो गया आपका कंसंट्रेशन ऑफ बी एट टाइम t. और टी हाफ इसके लिए आएगा आपका b नॉट बाई 2nk, where n is 2, so b नॉट बाई 4k. ये आपका टी हाफ हो गया बी के रेस्पेक्ट में, ये टी हाफ हो गया ए के रेस्पेक्ट में. टी हाफ ऑफ लिख देता हूँ ए टी हाफ ऑफ बी, ये डायरेक्ट डायरेक्ट हो गया, सॉल्व कर सकते हैं। ये डायरेक्टली सॉल्व कर दिया, इसको हम एक बार मैथमेटिकली भी सॉल्व करके दिखा देता हूँ जिससे कि आपको लोग कंफ्यूज ना हो। तो मैथमेटिकली सॉल्व करते हैं इसको ऐसे, a plus 2b gives product, rate is given as k, and from first lecture we can write rate is equal to minus dA by dt minus 1 by 2 dB by dt. Okay, so first take dA by dt, so minus dA by dt, so this is first equation, this is equation number 2, so minus dA by dt is equal to k, so dA is equal to minus k dt, integrate it from 0 to t, a naught to a, so a minus a naught is equal to minus kt, so a is equal to a naught minus kt, which is similarly for a gives product, and similarly t half is a naught by 2k. Okay, now we have this also, so minus half dB by dt is equal to k, so dB is equal to minus 2k dt, so dB is equal to minus 2k dt, integrate it, dB is equal to minus 2k, 2k is constant, dt with 0 to t, 0 to t, that is at 0 पे this is v naught, this is b, so b minus b naught, so minus 2kt, so b is equal to b naught minus 2kt, and for t half of b निकालने के लिए हम वही करेंगे, here this is b naught by 2, this is b naught minus 2k t half, b naught minus b naught by 2, so b naught by 2, b naught by 2 is equal to 2k t half, so t half of b, this is t half of a, is equal to b naught by 4k, which is same as here. B is equal to b naught by 2kt, b is equal to b naught by 2kt, t half of b is b naught by 4k, t half of b is b naught by 4k, a is equal to a naught minus kt, t half of a is a naught by 2k, a is equal to a naught minus kt, t half is a naught by 2k. ये प्रूफ हो गया। सो जीरो ऑर्डर रिएक्शन के सब केस, स्पेशल केस भी यहाँ पर खत्म हो जाते हैं, इससे तो कोई स्पेशल केस जीरो ऑर्डर के लिए आएगा नहीं आपका। और जितने ग्राफ आपके हो सकते हैं सब ग्राफ भी मैंने आपको करा दिए हैं जीरो ऑर्डर के लिए। आपको एक रियल टाइम एग्जांपल भी दे दिए जीरो ऑर्डर के कौन कौन से एग्जांपल हो सकते हैं। ये ग्राफ हो गए और जितने टाइप के क्वेश्चंस बन सकते हैं। ये क्वेश्चन थोड़ा सा डिफरेंट क्वेश्चन है, क्योंकि इस क्वेश्चन के लिए आपको एक गैस करना पड़ता है कि आप पहले गैस करिए। अगर आपने मान लीजिए यहाँ पर सेकंड ऑर्डर रिएक्शन होती है, आपने फर्स्ट ऑर्डर रिएक्शन गैस किया होता तो उसके रेट लॉस चलते तो K1 इक्वल टू K2 नहीं आता। जब नहीं आता फिर आपको फिर गैस चेंज करना पड़ता है, सेकंड ऑर्डर का गैस करते हैं, सेकंड ऑर्डर का गैस करते फिर रेट लॉ लगाते, जब तक K1 K2 आता तब आपको लगता है, पता चलता है कि आपका ऑर्डर ऑफ रिएक्शन जो है वो सेकंड ऑर्डर है और रेट कांस्टेंट हम निकाल पाते हैं। तो थोड़ा सा लेंदी क्वेश्चन है ये, लेंदी। अगर गैस सही पड़ गया तो ठीक है, गैस सही नहीं पड़ा तो ठीक नहीं है। इस टाइप का क्वेश्चन है ये, थोड़ा सा हिट एंड ट्रायल करना पड़ेगा इसमें, और इसका कोई सेकंड ऑप्शन नहीं है। दूसरा तो बस यही है कि अगर आपने जो दिख जाता है सामने से 20% कंप्लीट होने 40 मिनट लग रहा है, 40% कंप्लीट होने 80 मिनट लग रहा है, 20 से 40 जा रहे हैं, 40 से 80 जा रहे हैं, तो 40-40 मिनट मतलब नेक्स्ट 20 के लिए में 40 मिनट और लगे। इसका मतलब है कि सेम टाइम के लिए सेम सेम पर्सन कंप्लीशन के लिए सेम टाइम लग रहा है। इसका मतलब ये यूनिटरी मेथड को फॉलो कर रहा है, यूनिटरी मेथड फॉलो कर रहा है तो जीरो ऑर्डर रिएक्शन है। आप इस लॉजिक से भी सॉल्व कर सकते हैं, लेकिन वो लॉजिक सिर्फ जीरो ऑर्डर में लगेगा और फर्स्ट ऑर्डर के रिएक्शन के लिए डिफरेंट होगा, सेकंड ऑर्डर के लिए डिफरेंट होगा। तो वो हर जगह नहीं रख सकते। जीरो ऑर्डर तो आप डायरेक्टली निकाल सकते हो, उसके लिए गेस करने की जरूरत नहीं पड़ती है। लेकिन तब भी आपको अगर बोर्ड एग्जाम के लिए सॉल्व करना है तो आपको ये स्टेप्स दिखाना ही पड़ेगा।